Hello, and welcome to AnyLogic's webinar on delivery fleet optimization with GIS functionality. I'm Tom Maglio, Senior Solutions Architect at AnyLogic, and I'll be presenting this webinar today. Feel free to send your questions into us via the chat, and we'll be responding to your questions as time allows. Today, we will build a simulation of an aircraft part manufacturing service network of regional airports. We will also extend the simulation to include an optimization experiment to determine the ideal number of vehicles required to maintain a targeted fleet utilization. The model will be comprised of several agents consisting of a network of regional airports, a single manufacturer, a fleet of delivery trucks, and orders. We will utilize the integrated GIS functionality to locate the agents in the model as well as automatically determine the routes based on the roads from the GIS provider. Orders will be created by the airports and received by the manufacturer. These orders will be represented as agents and communicate between the airport and the manufacturer. After receipt of an order, loading the truck will be simulated with a process logic embedded within the manufacturing agent. Once the truck is loaded, the order is delivered to the requesting airport and unloaded and sent back to the manufacturer. Let's get started. First, we'll create a new model. In AnyLogic, we can create a model a couple different ways. One is to utilize the toolbar located up at the left-hand corner of the development environment, where we see File, Edit, View, Model, Tools, etc. We can create a file new model and create the model from there. Or another way is to use the shortcut icon located just below the toolbar, and we can create a new model like so. Now we'll answer this dialog box. We'll name this model Airport Delivery. And this model, or this dialog box, will contain the information we need for the model, such as the location of the model on our computer system, as well as the model time units. Now we can change these model time units here, or we can change them in the model, which we'll do during the course of development of this model. So here we see our development environment, and what we have on the left side are the Projects and Palette tab, and on the right side are the Properties tab, and in the middle is the canvas, which we'll be using for creating our logic. Palettes tab has a number of different libraries, process libraries, agent-based libraries, space markup, etc. So let's get started by dragging in a GIS map object into our canvas. We'll locate that in the View window, and let's expand the size of the map by dragging the map out to fill the entire size of the window. And we see we have an interactive map in our model in the main agent. If we single click on the map, we can change the map's properties, and we'll take a quick look at that right here. So the map has a name, the map has a tile provider, which you can select different tile providers such as MapQuest, etc. Routes are calculated from a OpenStreetMap server, routing method, fastest or shortest route, and road types can be selected. And we'll select the shortest route for this model, and we can select a vehicle or car, roadway, or a bike, or hiking. So once we have the map in place, let's save this model. And now let's create some airports and airports agents. So we'll use the map to find local airports. So double click on the map, and we can pan and zoom as the map is fully interactive with AnyLogic. And we'll zoom in the Midwest, specifically in the Chicago area, like so. And from there, we'll use the search, center that map. We'll use the search engine provided by the map provider, and we'll search for points of airports. And we'll get a whole host of airports that are visible in this region, and we'll start clicking on them to select several of the airports. We're going to specifically select 8 of these airports, but it doesn't matter. You can select as many as you want. And we're just going to go down and click the airports that have been presented in our search window from the search results. We're doing that right here. And you see we have these airports highlighted. We'll right-click, and we'll convert those to a GIS point on the map. And you see those icons have changed to an orange color. And now let's get rid of the rest from the search results and only display the network of airports that we're going to be using in our model. Next, let's look for a city called Elgin, which is where we're going to locate our manufacturing plant. We'll select Elgin, convert that to a GIS point, and get rid of the rest. And there's Elgin. Now, we want to go ahead and create a collection of airports so that we could use these in our model. So we're going to highlight every single GIS point in there, and we'll deselect by right-clicking Elgin as an example to remove the manufacturing plant from the airport collection. Right-click, create a collection. Now let's adjust the collection properties. Let's change the name of this collection to airport locations. And this is an array list of GIS points with the 8 airports that we've selected from our search. So now we'll create an agent. And we'll do that by selecting the agent palette. We'll drag the agent wizard, the agent icon, which will create the agent wizard option where you see a population of agents and single agent, etc. So we will create a population of agents. We'll rename this airport. And we'll answer the questions through the wizard. So we'll choose an animation. The animation we'll choose for the airport is this building right here. Click Next through the wizard, and if we want to add parameters we can, but we won't at this time. And we'll let the collection create the agents, so we'll create an empty population right now. So we'll finish that, and now we've created our agent airport. Now you can see the properties of the airport agent. Now let's add some values in there. So instead of defining the number of airports, we'll actually read that from the collection that we've created. So we'll use our code completion, which is just shift space, and we'll dial through and select the appropriate arguments and commands from the pull-down list as we type. And so this will define the initial number of agents based on the size of the airport collection. We'll define the initial location of the airports at runtime in a specific position or a node, which we're going to change this to a dynamic value. And we want to use the airport location collection as well. Only this time, instead of the size, we're going to use the location of those airports. And we can hit that light bulb to give us an idea of what argument it's looking for in this function, which is the index, which means it goes out and populates the agent location of the entire collection all at once at runtime. Okay, so let's run this model to see the effect. And at runtime, we see all of our airports at the positions that we found in the map. And Elgin, you can see, is not an airport and is not part of that collection, but is still there. Save the model. Now let's create a manufacturing agent. Once again, we'll use the agent palette. We'll drag in the agent icon, and we'll walk through the agent creation wizard. And a manufacturer in this model is only a single manufacturer, so we'll create a single agent. We'll select that. It's a new agent type. Walk through the wizard. We'll name that manufacturing. Walk through the wizard. Continue on. Select next. Choose an animation for the manufacturer, which is the factory. And continue through the wizard. And if we needed to add a parameter, we can, but not at this time. And then we'll finish that, and we've created the manufacturing agent. And we'll adjust some of the properties of the manufacturing agent. Looking at the initial location, where is the manufacturer going to be located? It's going to be located, as we discussed earlier, Elgin. Let's run the model and see the effect. So here we see the manufacturer located in Elgin, and the airports are unchanged. Close that. We'll save the model. Now let's create a truck agent. Again, go to our palette, drag the icon for an agent, and the trucks will be a population of agents. And we'll walk through the wizard as well, naming the agent truck, giving it an animation, which is this lorry or this truck. And here we will add a parameter which we will use in the model. And this parameter will be entitled client, and the type of this parameter is an other, which actually is going to be referred to as the airport agent. We will create an empty population of agents, and we'll fill that in through the properties. So let's bring in a parameter into the model. And this parameter will name as the number of trucks. Number of trucks. And this will be a type integer. We'll select int, and we'll give it a default value of 5. So there'll be 5 trucks in our model. Now, since we haven't declared a initial number of agents or the location, let's do that now. So where are the trucks going to be located? They're going to be located in Elgin, which is where the manufacturing facility is. Now let's create an order agent. Once again, drag the agent icon. And we'll create an agent type this time. And this agent type will be called an order. And we'll walk through this. This will not have any animation because it doesn't make sense in the GIS space we're working with. and we will add a parameter, and we will name this parameter customer, which we will use in the model. And this again will be a type of airport or other associated with the airport agent. Going back to main, let's save the model. Now let's create a truck resource pool. So inside the manufacturing agent, we can click on the object in the main agent, or we can click on the agent underneath the projects, and then we will create a new tab called the manufacturing tab, which is a representation of the agent itself. And from there, we will include our process modeling library elements. And so the first one is going to be the resource pool. Drag that icon out, and let's start adjusting its parameters. So this will be named trucks. We'll change its capacity to read from the number of trucks parameter that we have located on our main agent, and the new agent resource will be called a truck. And here we can adjust speed if we need to, and the units as well. This will be a custom population, and we're going to change that to a dynamic value and refer that back to the main agent, which is the truck population itself. Let's run the model. And we see the truck now is located over the factory in Elgin. To the GIS model, or the GIS shape. So let's go in and adjust that now. So we do that by going into the truck agent, and we can come in and adjust the properties of that truck, and there's a scale underneath the position and size feature, and we'll change that to 40%. Now let's see the effect of that. We'll run the model. And we see a more appropriate sized truck that will give us a better representation and visualization as we run this model. Okay, let's save this. Now let's create airport states and orders. Okay. So we'll go to the airport model, and we will drag in from the agent palette, or the state chart palette rather, the state chart logic into the airport agent. So here's a state. Let's create a second state, and we'll change these properties. So the first state is going to be named normal work state, and the second state will be the waiting state. Now we need some transitions to change from state to state, and we'll create these here. And we'll make those connections from state to state, and we can adjust the properties of the transition. And this transitions will be a rate of 7 times per week. This will be used to create the orders. Let's create a return transition. We'll drag those connections to the appropriate positions, and we can see the direction is going from waiting to normal. And let's adjust this transition. First, let's adjust the waiting state. We're going to create an order here. So when we move from the normal to the waiting condition or the waiting state, we're going to create a new order, and we're going to associate with the command or the argument this all of the information from this agent, which happens to be the airport. And we're going to send that order back to the manufacturing agent inside the main agent. So we're creating an order. It's an order type. It's associated with this airport. It has everything with that airport being pointed to it. And it's called an order. And inside that order, we created another parameter called customer. So this state creates the order and sends it to the manufacturer. Which is located in the main agent. Okay, and that's going to occur at 7 times a week. Now, let's adjust the transition to move back to a normal condition. What triggers this transition is the receipt of a message called delivered that will change the state of the airport agent from waiting to normal working condition. Now let's create manufacturing agent and order processing. So we'll go to the manufacturing agent. We'll start creating the logic for loading and unloading the trucks. So we'll use our process modeling library. We'll drag in an enter block. That enter block will be used to move the order agent through this logic, which we will do in a few minutes. So that is going to be using the order that will be traveling through this logic. Use the seize command. So the seize command will seize a resource, which is from the resource pool of trucks. Let's adjust its properties. Let's associate that with the resource unit. Let's use the flashlight icon, and we'll just click on resource unit of trucks, and we see that gets populated in there. And instead of having a queue capacity that's fixed, we'll have an unlimited queue capacity for this seize. So it'll be based on the amount of trucks that we have. Now let's create a parallel process of once we've received an order and seized a truck, let's start loading this truck. So we'll do that with the resource task to start block. And again, this will be the truck agent. And we'll bring in a delay to simulate the amount of time it takes to load or pack the truck. We'll change the properties of the delay. We'll change that name to packing. And we'll change the delay time from the default triangular probability distribution. We'll change that to a uniform distribution. And we'll do that through our probability distribution icon located up in the toolbar. And here we see a whole list of various distributions to choose from. And we'll choose the uniform distribution. and we'll enter in the parameters of 2 to 3 to represent 2 to 3 hours it takes to load a typical truck. And we can see how that distribution will look in our model. And that gets populated in that field. We'll change the time units to hours. And logically, we will not limit the capacity of the delay, or the of this delay icon. Now, after we've packed the truck, we're going to move to the airport that's requested the delivery. So we're going to move to a block. Rename that to airport. And select a destination. The destination is going to be an agent. Now the destination will be determined from the truck's parameter called client. So right now we're going to enter in the agent, which will be agent with parameter client, and the agent here refers to the truck. And we haven't assigned the airport to the client parameter yet. We'll do that in the C's block in a moment. So let's connect the move to the C's block, straighten that out. Now, let's assign the airport which we've received from the order to the truck's parameter client. And we do that right here. Once we seize the unit, which will be truck, and here's the parameter client, and we're going to assign that from the order customer, which is the parameter which has the airport located in it. So now the truck parameter client has the airport location. We'll add a delay. Once it arrives at the airport, it will need to be unpacked. We'll change this delay to unpacking, and we'll adjust the time of unpacking similar to how we did the packing delay by highlighting the delay time, selecting the probability distribution icon, and then we'll select a uniform distribution, and again 2 to 3 hours will be the unpacking time for this truck. Change the time units to hours, and we'll change the capacity of this delay block to maximum so that we will not limit it. So on exit of the delay, we will need to send a message that we have delivered the products to the airport, which in this case is the customer parameter. So once we've finished, the airport that has ordered that product now will receive this message, and if you recall, we have a process in the airport agent to do something when we receive a delivered message. So now once the truck is unpacked, we're going to release this resource, and we'll add a sync to the end of this logic so that we complete the logic string, but we need to release the truck, and we need the task end, the resource task end parallel logic which we're going to add right here. So once the truck is unpacked, we'll move the truck back to the manufacturer. So we'll bring in the move to block. We'll add a connection from the release to the move to block, clean that connection up, and we'll adjust some of the parameters of the move to block. Adjust the name. Move it to an agent, which in this case will be the manufacturer. And again, the manufacturing agent is located in the main agent. And now we'll need to end this parallel task with a resource task end. Adjust its position. And now we have the process logic for processing the order and delivering the truck, and delivering the parts with the truck. We're going to use the connection to place the received order message into the enter block. What this does is that when that order is received by the manufacturer, it will put it into the enter block, and that order agent will move through that process library, or that process logic step. Let's run the model. Oh, as we said earlier, we were going to change the model time to days, and we can do that through the properties of the project of airport delivery. Now let's run the model. There's two ways to run the model. We can actually select it through the simulation agent or class, or we can do it through the main library or the main toolbar. Here we're adjusting times, and we will see trucks moving down the roads delivering parts from the manufacturer to the airports and returning back to the manufacturer. So we can speed things up and slow things down in terms of model time. Notice that trucks are following the roads that are created by the map provider. Stop the model. Save this. Now let's check the truck utilization. So let's run this model and start diving into some of the data that's being collected by the various products, or by the various logical steps. So running this model, slow it down a bit. We'll stop it at various points. Let's pause the model. And here we see a truck returning. Let's go into the manufacturing library, and we can see, okay, there is a truck that has been seized. There's one that's being packed. There's one that's returning back to the manufacturer. One that is at a delivery of an airport, and we have 2 out of the 5 being utilized. So that is matching up with the actual visualization on the simulation. We can check it a few more times. Again, move back to the manufacturing. We see we have 1 in unpacking, and we have 4 out of the 5 available. Let it run some more. We'll stop the model at this point. Let's go take a look at the utilization. We have all of our trucks are out, 2 are in at airports, etc. So we have 2 en route to an airport, 2 at an airport. Let's take a look at that again. We have 3 being unpacked, 1, 2, 3. And we see that as well through the airports. We can index through the airport agents. We have 8 of them, and we can see that there are some airports waiting for materials, others in normal working conditions. And we can scroll through those, and you can look at the various states in the model. Again, you can go in and look at any of those features as you're running this model. Here we have our speed up. We can run it to maximum speed. Now we can look at a steady state condition of our utilization of trucks, and we see that at 5 trucks, as we're moving through time, we're running at around 45% truck utilization. So now let's try to answer the question of how many trucks would I need for a targeted truck fleet utilization. So let's run an optimization experiment here. So we'll do that by creating a new experiment. And that'll be an optimization experiment from our experiment types. And we will use the outputs of that to copy into the simulation once we get the optimization results that we're looking for. So now we'll adjust the properties of this optimization experiment. Let's set an objective function, and that objective function is going to be, we're going to maximize the truck utilization, which is found at route. Route and main are synonymous at this point. So we use our code completion, manufacturing, trucks, utilization. The parameter that we've pulled in from the main library or the main agent is number of trucks, which we see here, and we're going to adjust that value from 1 to 5. So the optimization engine will actually go in and adjust and alter that to see the results based on the simulation of truck utilization. But let's establish a requirement, which is our targeted fleet utilization. So once again, we'll go back to the route, and we'll set the manufacturing truck utilization. And we'll set that to a realistic 85%. So it has to be less than or equal to 85%. So we'll use the create default UI or user interface, and that will create our optimization engine experiment UI. Let's run that. And here we see the various permutations of the runs. We see what is currently being run, and it's running the simulations, running and changing and adjusting the variables, and it's looking for answering the requirement of less than or equal to 75%. And the optimization experiment is completed, and we found that 3 trucks will give us about 73% or 72.5% optimization or utilization in our fleet. So we'll copy that result into our simulation and validate that. So we'll paste from the clipboard, and we see the number of trucks parameters now has been set to 3, and we'll run the simulation. And we see the number of trucks is set to 3. Now let's take a look at the utilization. And we see that a steady state is right around 70% with 3 trucks, as opposed to 40 to 45% with 5 trucks. Speed the time up, and we can see that right at 72%, 70 to 72%. Save that model. Great. Thanks for joining us. Now we'd like to address some of your questions that you may have. And once again, we will be sending a email out to all the attendees for any specific questions that we could not address due to time. So we have a few right here. One of the questions is there a way to change the visualization in the simulation so that it's easier to see an airport that is ordering or waiting for parts? And yeah, there is a fairly easy way to do that. Here's what we've done in the past. So we go to the airport agent, and what we'll do is we'll add a fairly simple indicator to the airport animation so that we'll know when the airport is in the state of waiting. So what we've done in the past is, like I say, is we put in a very simple object, such as this oval, and this will just be an indicator. We'll drag that to the animation of the airport, so this circle will be displayed as we control it. And let's change the properties of that circle. Let's make it red. Let's change the line to red. And so now what we want to do is we want to change the visibility of this circle, that when it's in the waiting state, this indicator is on and visible. So we can see from the model that, hey, this airport is waiting for a delivery. So we'll go ahead and change that to a dynamic value. And we will use our code completion. And we'll use the state chart. Is state active? And we'll type in waiting for details. And so what this will do is, when the airport is in a waiting mode, which means it's ordered parts, this icon will show up. The circle oval will show up, and it will be red. So let's have a look at what that looks like. Oops. So let's slow that down. And let's pause the model. And so we can see we have this airport is waiting for a delivery, and there's a truck that's moving out to it. And so this gives us another way of verifying that the model is logically behaving correctly. All the trucks are moving to an airport that's requesting a delivery, requesting parts, and they're returning after they've delivered a part, after they've made their delivery, returning back to the manufacturer, and so on. So this is a good way to look at the visualization and verify that logically your model is working properly. Okay, another question is, what happens when I change the factory location? What's the impact on utilization? That's a very interesting question. So let's go ahead and do that. I suspect it will change the utilization if we move the factory location. So since the map is interactive, let's go ahead and double click on this map. We'll zoom out. zoom out to here. Okay, and so we still have our airport locations here, so we'll choose a location, say, pick it St. Louis. So we'll search for St. Louis, we'll find St. Louis, we'll get rid of the rest, and now we have a GIS point of St. Louis located on our map. Now let's change the location of the manufacturing agent to St. Louis instead of Elgin. Now I can use this flashlight, go in and click St. Louis, and there I have St. Louis. And let's also change the trucks from Elgin to St. Louis, and I can do that through the pull down if I'd like, or I can do it through clicking over there. And now let's run the simulation and see the effect. So now we have our trucks moving in, and if we want, we can still pan and zoom, and I can zoom in, and it's still interactive, and the trucks are moving in and out of St. Louis to the various factories, and you can see that there's deliveries going on and orders just like we had before. We actually see more orders here, so it's an indication to me right away that, hey, locating this factory farther out, as you would suspect, is going to create more of a lag time. So let's go in and let's see what the utilization looks like. And we see that utilization is right around 96%. So basically every truck is utilized, and it's because it's spending so much time moving to and moving from the delivery mode. So let's run an optimization experiment real quick to see the impact of that. And it's the same conditions in the optimization experiment. We're going to run through 5 trucks, and we'll run this optimization experiment, and we'll see if we can get something less than 85%. So it's going to run, and everything will come up at the result, either it's feasible or infeasible. So we've run through as we run through the steps, we can see the results of the utilization, and we've completed the optimization run, and the best infeasible result is still at almost 100%, and we've run through all 5 permutations. So that tells me that we need more trucks in this fleet, so let's go ahead and adjust that. Let's just choose 10. Let's run that optimization experiment again. The size of our fleet of 10 trucks. So it's going to run through the 10 permutations of that, and we'll see if we achieve less than 85% utilization with something 10 or less. We know we didn't hit it with 5. So it's running through the simulations, as you can see down here on the user interface, and it's moving through the optimization. And we're starting to hone in on less than 85%, and at 8 trucks we're at 70% and still finding more. Okay, so at the end of this optimization, we can see our best feasible solution is 7 trucks running at roughly 80% for the simulation time that we've chosen in the optimization. So let's go ahead and copy that into our simulation, and let's go to the simulation. Let's paste that in. We have 7 trucks now, and let's run that real quick. And here we have our delivery now of 7 trucks. Let's go ahead and position that map a little easier to read. Zoom in. Once again, the map is real time and is active even at model runtime, and we can see the delivery of the trucks to the airports. Let's go in and look at that utilization, and we can see we're running at roughly 84 to 83% with 7 trucks, which is much better than nearly 100% with 5 trucks. So the answer to the question is yes, location of the manufacturing facility will have a very significant impact on utilization of your fleet. So this is very helpful in making a decision on where should I locate my, my facility, my factory, and what is the fleet size I need to accommodate my customer requirements. See if we have any more questions. We have a couple more questions that came in. Model runtime. What is the length of the model runtime, and how do you control that? Yeah, that's fairly simple. Model runtime is controlled in the simulation underneath model runtime properties, and in this case the model runtime is set to never end, but you can set that to anything you want, stop at a specified time or a specific date, etc. However, in the optimization run, the model runtime is set to run for 100 model time units, which is in this case days. And the reason for that is we run at 100, each simulation run based on the parameters changing will run for 100 days, because that's what we needed to get it to a steady state on utilization. If we ran it just for 1 day or a very short period of time, the utilization didn't reach a steady state. So you can control that through these properties. Well, that's all we have for time for now. I'd like to thank everybody for attending, and once again, we will send you the model that we've created with the experiments and the complete transcripts of creating the model, as well as we'll post the webinar on our website. Once again, thanks everybody for joining, and look forward to seeing you at the upcoming webinars. Bye-bye.